All right, in this video, we're going to look at the difference between distance and displacement. So in this situation, you're somewhere, and you travel 9 miles north, and then you turn around and travel 2 miles south. I'm not sure if this is entirely the scale. So your distance is simply how far you walked. So if you walked 9 miles north and 2 miles south, congratulations, you've just walked 11 miles. It's kind of a lot of miles. Your displacement, on the other hand, is basically the difference between where you started and where you ended. So if you began here and you ended here, how far are you from your starting position and in what direction? So if I went 9 north and turned around and went 2 south, hopefully it makes sense to you that we are 7 miles away from our starting point. I should clarify, this is start and this is end, not south and east. So we are 7 miles north of our initial position, so our displacement is 7 miles north. We have to include the direction as part of our displacement because it's something called a vector, and vectors have direction. So your distance, you just add them up and get a total. You still should have a unit, but there's no direction. Your displacement, on the other hand, will have a unit as well as a direction. So let's look at another one like this. So here I have a lot going on. I could sketch this out, but it kind of gets ugly fast. So 4 miles north, and then I go 7 south. So, I can easily lose track of where this is. And then 2 north, and then 3 south. You can sketch it out, but the easier thing to do is just to lump things together. Actually, before we do that, let's do the distance. The distance is easy. I go 4 north, 7 south, 2 north, 3 south. All you do to find distance, just add everything up. So 4 plus 7 plus 2 plus 3, that is your distance. So in this case, it's 16 miles is your distance. Your displacement, the best way to figure that out is to lump things together. So here I've got 4 north and 2 north. It actually doesn't matter the order. Together, that equals 6 miles north. So I'm going to combine those. And I've got 3 south and 7 south. So together, that's 10 miles south. I'll combine those. So then we combine this with 6 north and 10 south. Overall, that's going to be 4 south because this, 10 minus 6, 6 of these miles cancel out. If you go 6 north and 10 south, it's going to take 6 to cancel, and you'll be left with 4 more. So basically, the displacement will be 4 miles south. Your distance will be 16 miles. So that's how you do a distance displacement type situation. Now, it can get more complicated. In my class, I don't think we'll go to this length, but for example, here, let's say you start somewhere and you go 4 miles north, and then you go 3 miles east. So in this situation, the distance is just 7 miles. You walk 7 miles total. Your displacement, though, is this, and this is at an angle. It's not simply a matter of adding and subtracting. The only real way to do this is to use the Pythagorean Theorem. So if we call this c, it'll be 4 squared plus 3 squared equals c squared, which is 16 plus 9 equals c squared, which is 25. So your displacement in this case will actually be 5 miles, and it'll be in a northeasterly direction, but it's not perfectly northeast. We could, if we really wanted to be technical, find the angle and all that. That gets a bit more complicated. Also, you can have problems where you go north and then you go at an angle, and I'm not getting into those in here. But occasionally, if you ever see one like this, just realize the Pythagorean Theorem would be helpful to find your displacement. But your distance is always very simple. You're just adding up each leg to get a total. But in this case, again, displacement would be about 5 miles northeast, and again, northeast is not the most specific descriptor. But anyway, that is distance and displacement, so try those out. Until next time, I am Derek Genova. Have a delightful day.